Hey guys, this is Justin back with an engineer's perspective, and today I've got a little bit of maybe a rant video for you, but we're just going to get into it and see where this ends up exactly. But what we're going to be discussing today is I see a lot on the internet forums or wherever people will say things like, oh, I wish I had this big chopper in something like, 3V and to do X, Y's, and Z's. Or something like, more common what I see is, like the Spyderco Shaman. Oh, the Shaman would be great in something, like 3V or, something like that. And I completely disagree. I think that 3V is an objectively bad steel for something like the Spyderco Shaman. And I'm going to discuss why I believe that. So when a knife is made, there's things that come together that will create a good knife. And basically you need to match these elements to the intended use of the blade. Those things are the steel, the heat treat, and the geometry. Those three things have to match the intended use. So first, let's actually talk about the pocket knives. I don't even know why I took that out. Let's talk about the pocket knives. So we've got two pocket knives here. They're both Manix 2s. This is a lightweight and Maxamet. And this is the standard in crewwear. So I think this one is an okay example of a well-matched knife. So you've got this lighter weight handle on it, meaning it's probably not going to be used for super hard use, right? And it's just a small pocket knife, so that kind of limits the amount of force you're going to be exerting on it in general. So how do you match steel heat treat and geometry to just like a work knife that's not going to be smacked into things and pried as much? Is you use a steel like Maxamet that has and it's at a very, very high hardness. So let's say it's 69 Rockwell, meaning it has low toughness. So do you need a knife that has high toughness in a form factor like this? The answer is no, it doesn't need to be very high. And because of that, you can choose a steel that has lower toughness and you can put it at a high Rockwell. So does Maxamet meets both of those things? Nice work. Now you have to decide what you do with the geometry, right? Because this is where people get it wrong. Is if I made this blade twice as thick, I could make this thing out of glass and I probably wouldn't have to worry about it breaking. And that might be an exaggeration, but do you see the point? Is if you make a knife's geometry so thick, it doesn't matter what steel you make it out of. So here, they've gone with the standard Manix geometry, which is for a stock thickness, very good, but a little bit thick behind the edge, maybe 23 thousandths behind the edge at like 17 degrees per side. But, the Manixes are more like working knives, in my opinion, compared to like the paramilitaries even. So I think that little bit thicker geometry matches for somebody who's going to be using it a little bit more recklessly, but not crazy as pocket knife lightweight handle. So that geometry being a little bit on the thick side kind of matches a knife that's going to get used hard, but like within its realm. So they've matched the steel and the heat treat and the geometry on this one, right? So same exact knife where they did not do that. So everything is the same, everything I said. You've got the standard handle, so maybe a little bit harder use people will do with it. But now we've got crewwear, which is very tough steel. So crewwear does not need this kind of geometry because it's a lot tougher than Maxamet. So sometimes people will say, oh, the Shaman would be great in crewwear. No, it won't. The Shaman is so dang thick, you could make it out of enter chippy steel here, S110V, and it would be fine. So it's a bad candidate for tough steel. If you've got thick geometry, you should be shooting for something extreme in that steel. Don't double, triple, quadruple down on design elements, okay? So like this one came too thick. It came with standard geometry for crew wear and for a pocket knife. So I had this one reground to now it's about 8 thousandths behind the edge. This crew wear is like 61, 62. It's got a very stable edge. It's very tough, so it can do that. So the chemistry makes it tough. The heat treat makes it stable, because if this was run soft, then it wouldn't be able to hold this acute geometry. So it's tough and it's hard, and its use case means that I'm not going to exceed this, right? So they've matched the chemistry, the heat treat, and the geometry. Well, I've matched the geometry to those elements, but before it was not. So do you see that? Same knife, different steel, where the geometry makes some sense on the lightweight with Maxamet, but it does not make sense for the crew wear. So let's look at some bigger knives, right? So you've got an SE6 in 1095 at like 56 Rockwell. And you've got, is that 1/8 inch stock? I believe it's 3/16. Yeah, I'm pretty sure it's 3/16. Let's see if I can tell here. That is the wrong side. No. Yeah, it's 3/16. 3/16 stock, about 45 thousandths behind the edge at 20 degrees per side. So 1095, tough steel, not the toughest, but tough for sure. And this thing is meant for chopping. You can bend it, pry, basically indestructible. Okay, you're gonna want something tough in this, 100% agree. So does 1095 make sense from there? Yes, it does. Okay. The geometry, 45 thousandths, so 1095 run at 56 Rockwell. If you're smacking it into crap and twisting and everything, you're gonna roll that edge right away at a low angle. So the 20 degrees per side makes sense. You're basically using this thing as an axe half the time if you're chopping with it anyways. So the 45 thousandths behind the edge is too thick. It's too thick, but it kind of makes sense. So this combination of things makes sense. However, what I think makes more sense is something like this Spyderco Waterway, where on this SE, because it's with soft 1095 steel, they have to give it thick edge geometry. They have to. Whereas on this Waterway, you've got LC200N, very, very tough still, almost very similar, but this is at 59 Rockwell. So now it's 3 Rockwell points harder. It can hold more acute geometry, and I think this is a better route. So for the task, this is probably overkill, but it makes sense. They went for it. It's fine. But this makes more sense to me is, let's get a steel that's going to work for us. You know, like AEBL is another good example of a steel that's going to work for you in this outdoor utility chopping hard use range. And then that way you can drop the geometry down and get a much better performing knife. So this is a better execution than this is, in my opinion. So this knife should be made out of LC200N, and it should have half the thickness behind the edge at that 20 degrees per side. It'd be a much better knife that way. So, yeah. So this is this matches everything perfect for a harder use utility knife, in my opinion. And you see how much thinner it is and lighter and just everything. So now here's some examples of atrociously done knives. So here's the SE Azula, 1095, 56 Rockwell, 45 thousandths behind the edge. For one, I think it's 1/8 inch stock. Is this too small to get a lot of leverage on? And you're not smacking, even if you smack it into things, it's so light, it doesn't carry a lot of momentum. So you don't need the tough steel, you don't need it to be soft, and it's small, so you're gonna be doing delicate tasks. This geometry is way too thick. This is a miss in every way it can be a miss. This is awful. So that's a terrible example. Another example is, I don't have it anymore, but the Benchmade 200 Puko in 3V. So they originally were heat treating that at like 57 Rockwell, and the geometry on it was pretty decent though. It was pretty decent outdoor geometry. It's not overly thick like an SE. But why do you put a super tough steel and then make it soft? Like at that softness rating, you could have made it out of anything, any steel, and it would have been tough enough. Like the point of using a tough steel is so that you can take advantage of good geometry. So that was just dumb. And so now they've updated their heat treat on 3V in the 200 Puko to like 61, 62 Rockwell, I believe. That makes sense. It's a super tough steel. The geometry isn't super thin on it, but it's thinner than like an SE. So it all meshes together. Like it's so tough that you can run it hard, and it just performs so much better. It sharpens better. It holds the edge better. It does everything better. So make it appropriately hard. Don't take a tough steel with thick geometry and make it soft. You just did 3 things to make it tough, and all it needed was 1, and now you just made a shitty knife, pardon me, a crappy knife, by tripling down on it, you know? Don't say, oh, I think I need a truck because there's some snow here, but also I need a truck, then I'm gonna get it lifted, then I'm gonna get, these amazing, tires that have studs in them and fog lights and a tow kit. Like, you probably would have been fine doing this, but now it sucks to drive on the highway and you look like an idiot driving that thing around. Don't do that. Don't do that, okay? So I'm tired of hearing that the Shaman would be great in XY tough steel. It's too thick for that. It should be in Maxamet, okay? So that's my rant. That's all it is. I hope it made sense. When I look at knives, I say, does the use match the chemistry or the steel chemistry, the heat treat, and the geometry? If it doesn't, it can be tough for me to get on board. But anyways, that's all. That's my rant. I hope you enjoyed. Have a good one. Bye.